Hey everyone, it's Mrs. Conway, and today it's time to learn about one-step equations. So far we've practiced simplifying expressions, but now we need to talk about actually solving equations just so that you can remember that skill before we dive into our algebra curriculum. So remember, solve means to find the value of the variable. So that means that now we're getting x by itself on the left-hand side of the equal sign. So when we solve, we need to think of what undoes the operation. So we're thinking of inverse operations. And I know that pretty much all of what I'm going to give you for this unit is going to be stuff that you could do in your head. I get that. But I want you to practice using those inverse operations so that when we get to the more complicated stuff, you're really comfortable using inverse operations. So remember, inverse operations are addition and subtraction, and they undo each other, and then multiplication and division. So we're kind of going to have two types of one-step equation. The first kind are where we're adding or subtracting, so you have to add or subtract to undo, and then the second kind is multiplying or dividing. So right here, we have an addition example. So this one is m plus 12. So since we're adding 12 to m, to find out what m is, we want to subtract 12. And remember, whenever you're solving equations, whatever you do to one side of the equal sign, you do to the other side. So right here, I'm going to subtract 12 from the 12 to get rid of it. And then I'm also going to subtract 12 from the 10 to see what m will be. So these two 12s become 0, so they're gone. So all I'm left with is m equals 10 minus 12, which is negative 2. And then if I want to check that, what I should do is I should just think, okay, negative 2 plus 12, that is 10. So it's correct. So hopefully that was easy and you remember that. And you might have been able to do that in your head, but again, I want you to practice using these inverse operations so that you're good at it. All right, next is a subtraction example. But first we kind of have to find our variables. So again, this is our equal sign. Whatever we do to one side, we do the other. But instead of the variable being over on the left side, you'll notice it's over here on the right side. So we're going to get rid of the 9 because it's on the same side as the g. So since this is a subtract 9, we're going to add 9 to both sides of the equal sign. So these 9s, again, the 9s become 0. G minus 0 is just g. And then negative 2 plus 9 is 7. So 7 equals g, or if it makes you feel better, g equals 7. And then again, we might want to check. 7 minus 9 is negative 2, so we did it right. Okay, now we come down here. Again, I like to draw these dotted lines on the equal sign just to help me remember if I do it on one side, I have to do it on the other. But now we have to think, okay, what does it mean when I have 7y? Well, 7y is 7 times y. Remember, if the number and the letter are right next to each other, then they're being multiplied. So this is multiplication. So to undo multiplication, we have to divide. And remember, when we have a bar like this, that means divide. So to undo multiplication, we divide. So these two negative 7s, they actually become a 1. So 1y is just y equals negative 91 divided by negative 7. And this is a negative 7. I know it looks like it was all 1, but you have to divide by the actual number, not the opposite. So that becomes positive 13 because negative divided by negative is positive. And then again, we might want to check negative 7 times 13 is negative 91, sorry. Okay, last example starts with division. So now, in order to get rid of the division, we need to multiply. So rather than thinking of this like a fraction, I recommend you think of it like a divided by 9. So then to get rid of it, we're going to do times 9 on both sides of the equal sign. So the 9's cancel, again becoming 1. So we have 1a, which is just a, equals negative 4 times 9, which is negative 36. And again, just to check, negative 36 divided by positive 9 is going to be negative 4. This is the best time to kind of check your positives and negatives. So now, we've done an example of each, but I do kind of want to just do this last example here. So here, this one looks a little different than any of the other ones we've done. It is an addition example in a sense, but notice this is a negative 3. So most of you are hopefully thinking, well, but to get rid of negative 3, we would add. So really this is more of a subtraction example. It's just that it's written backwards. You've got the x after the negative 3. So you're right. We have to add 3 to both sides to get rid of this negative 3. So x would equal 13. And if you check, negative 3 plus 13 is 10. So I just wanted to do an example like this. It's just like when we were doing the expressions. The sign goes with the number after it. So this is a negative 3. So you could almost think of this like a subtract 3. So to undo it, we have to add. And the x is actually being added. It's a plus x. So I think with that example, you should be good to do the Delta Math assignment. That's all there really is to this. And then there, of course, will be some review of our old stuff at the end. So good luck.